This video presents the key concepts of inter-process communication over data networks. The focus of this presentation is on the widely used and very important HTTP protocol with application to web servers. Recollect that processes can communicate and coordinate with each other by sending and receiving messages, which is facilitated by the operating system. So processes on multiple computers can interact with each other over the network and also send and receive data over a data communication network. So this is how web servers are developed, and web server is a classic example of a program that uses IPC for interactions. Here there is a web server and a client that interact with each other, and they communicate with each other using the Hypertext Transfer Protocol, or HTTP. This presentation, we are going to do a deeper dive into how these interactions occur and some of the details of the HTTP protocol. Recollect that web servers are often used to streamline communication to send and receive information. There are two modes of operations for web servers. The first mode is when clients interact with the web server through a GET or a POST request. The web server essentially can take contents from a file and send it to the client. This is typically how images, some of the HTML data, and what's called static content on the websites are actually sent to the different web browsers. There's another mode of operation called Common Gateway Interface that web servers often support. Here, the web server, when a request is received from the client, the web server runs another program and takes the output from the program and routes it to the clients. Here, the output is obtained from the other program using anonymous pipes, and the data is sent to the clients. We are going to do a deeper dive into how the details of this web server system and with HTTP works. First, it's important to understand the inputs being sent to the web server. These inputs are generated by the web browser, and we're going to look at some of the details of the HTTP request that is the input to the web server. Recollect that given a URL, a web browser basically looks at the URL. Here it's HTTP protocol is to be used, and the browser looks at this URL and creates multiple lines of request to the server. The first line is called the GET request, which essentially has the URL or the path that is requested by the user. Then the web browser also includes the host information as specified by the user and some connection details. And note that each one of these lines are terminated by a \r/\n, that is 2 characters, and that's part of the HTTP protocol. And this only applies to the HTTP headers that are being sent and received. And this information is sent to the server, which is assumed to run in this example on CEC LNX 01. Keep in mind these header names are typically fixed, but the order can vary, and some of these header types require very specific values, like for example connection can be open or closed and things like that. Some of the URLs can contain non-printable or non-standard characters. In these cases, the web browser automatically encodes these characters using a hexadecimal value. So each character is taken and encoded into a hexadecimal value in the URL. So this is called URL encoding, that is used to transmit non-printable characters to maintain broad compatibility, and is used by all web servers, web clients today. The browser, of course, encodes the special characters in hexadecimal. Recollect that each one of these characters is 8 bits, so it can store values in the range 0 to 255, which is also called ASCII codes. A space is typically encoded as +sign or %20, where 20 is the hexadecimal value for the ASCII code of space. Every one of these special encoded characters starts with a %sign followed by 2-digit hexadecimal values. So for example, given this type of input, each one of these special characters are encoded into hexadecimal notation by the web browser. And it's up to the web server or our C++ program to decode these values. Decoding the values is pretty straightforward. It's just basic string operations. So typically, given an encoded string, we will scan the strings for these special characters, either starting with a +sign or a %sign. So we're going to keep processing this string as long as there is a %sign or a +sign. So depending on the character, if it is a plus, we simply change that one character to a space. Otherwise, what we need to do is to take two hexadecimal digits and convert it to a character. So for example, if the encoding is %2a, we need to convert it to a star. And that's what we do here. First, we take the two characters. Here in this example, we'll take 2a and store it as the hexadecimal string. Then we will decode the string. Notice that there's a base 16 to convert it basically to a decimal value, which is then stored in a character, interpreting that value as a character. And then we replace three characters, in this case %2a, with one character, which will be the star. And this is how the decoding is done. Pretty relatively straightforward logic. The web browsers can also send multiple inputs from HTML forms. So you can have these pretty standard forms in which user enters some input. And in order to send the data to the server, these inputs are supplied in the form of what is called a query string. So typically the query string will start with a question mark character, and you'll have multiple inputs values specified there. Each input is in the form name equals value. So the name is something that is predefined in the HTML form, and the value is the information entered by the user. And multiple values are separated by ampersand. Input form can have multiple fields, and each one of these fields are separated by the ampersand character. So for example, given this HTML form that is here, the input to the web browser will look like user is the characters that I've entered, and with URL encoding. And you'll see the ampersand character where the ID is the number 1, 2, 3. So when the user enters information like this, the web browser generates a string and sends it to the web server as part of the GET request. So here when we get these inputs, input processing involves two key steps. First, each name equals value pair should be separated based on the ampersand character, which is the input delimiter there. And then each name equals value pair should be further split on the equal to sign to get the name. Name is just some variable name as defined by the user. So you specify what the name is supposed to be, like the name of the variable. And the value is the information that is entered by the user. Keep in mind the value is always URL encoded, so you should always URL decode the value. Using the method we looked in the previous slide, you should do URL decoding before using this value. Now given this input, let's see how the HTTP response generated by the output or the output from the web server looks like. The HTTP response from a web server is basically plain text. First, it will start with a response status code. Here it's looking at 200 OK, which is the standard response on a successful processing of an input. The web server will generate several HTTP headers. Again, note that each one of these lines is terminated by a backslash or a backslash n. And the headers are terminated by one blank line at the end. Notice that at the end of content type, there's one blank line that delimits the end of the HTTP response header. After that, you will have the actual content that is in response that is sent back by the web server. Here the content sent is an HTML document, which was what was requested by the user. Note that HTTP and HTML are unrelated. You can also use the HTTP response to send binary data like images or movies and things like that. And here there are two key fields that are important. There are content length. Here it says 178 bytes, which is the size of the data that's being sent. And the content type is also important. That tells the web browser what type of data is being sent by the web server so that the web browser can suitably display that information. Another way to send HTTP response is called chunked response, and servers can send large pieces of data in small chunks. And chunked response is used when the size of the data is not known upfront. That means you're streaming some information. So data is coming, say, from a live video camera and you want to stream it. You do not know how much data is going to come. So you keep on sending chunks of data as and when they come. And this is also used to stream the data. That means you stream videos, live videos, and live streams this way. A chunked HTTP response must have the HTTP header value transfer encoding :chunked. Notice that the transfer encoding :chunked is important. And then this header must be followed by 0 or more chunks of data. A chunk of data includes two fields. One is the size of the chunk, followed by the actual data for the chunk. So first, you should print the size of the chunk, followed by the data for the chunk. Notice that here the size is in hexadecimal, so you should print the size of the data of each chunk in hexadecimal, and you can use the stdhex modifier in C++ to do that. And this size should be exactly the number of bytes in the data being sent in that chunk. So the size of your printing and the data you're sending for the chunk should exactly should match up for the bytes you're sending. Same way, you can send multiple chunks with the size and the data. And then finally, to indicate end of stream, you should send a 0 chunk followed by a blank line, which indicates that the chunk has ended. So make sure. So this is the sequence. This is the expected response that a web browser will expect. Of course, when you look at it in a web browser, you will not see the chunk sizes. You'll just see the data that's being sent, which will be 2 lines of data. Another field that is important in the response is the content type. Here we are looking at text plain, which means the browser should interpret this data as plain text. But there are different other encodings or content types you can use. So for text, HTML, the content type should be text HTML. For images, it should be image PNG or image JPEG, depending on the type of image that you're sending. And there are many such content types, but these are the more commonly used content types. So for example, to determine the content type is very straightforward. Typically how it is done is you extract the extension, the file extension from a given file. So for example, here, if the file requested had an extension XXXX, this substring ext will have the suffix XXXX from the file. And then if the extension is HTML, the content type is assumed to be text HTML. Same way for PNG, JPEG, GIF, icon. So you can have different types of file extensions and corresponding content type to be sent. By default, if you don't know the content type, you assume it's text plain. That's typically the default. Now let's see how we can use this information to send a chunk response from a file. So here we'll create a method called sendFile, where we want to send the contents of the file, not the file name itself, but what is inside the file, what is the content of the file, to a given output stream. So here we open the data file. It's a good idea to check to ensure the file is valid. If not, typically in HTTP you will send what's known as a 404 error message. Here we'll assume that the file is valid. So we're going to generate a standard 200 OK, a header. Notice that we're saying transfer encoding chunk. That means we're going to send the data in the file in form of chunks. And we're setting the content type of the file based on the path that was requested. And we saw this get content type method in the previous slide. And notice the use of \r\n to terminate lines and a separate \r\n to end the headers. Now we're going to start streaming the contents out. And we're going to do that line by line. So we have a standard for loop that's going to read a line from the file. And then notice that we have to add a \n because this \n is consumed or not included by getLine, because \n is the delimiter for getLine by default. So we have to add that \n because it was in the data. It's just that getLine doesn't give it back to us, so we need to add it back. And then we print the chunk. So here notice that first we print the size of the chunk in hexadecimal, followed by \n, and then we print the actual contents of that line, followed by \n. And this for loop keeps on running, printing line by line by line of the file in small chunks. And then finally we end the series of response with a 0 chunk, which indicates the chunk is done. So it's a very simple read line by line and print data is pretty much what you're doing here. And this one essentially generates this chunk response. That's what this method essentially does. Now let's see how we could do the same approach using anonymous pipes to send output from a program as a HTTP chunked response. So here we're going to just use some named constants to keep the code readable. Then we're going to develop a method called send command output that's going to run a fixed command and then send outputs to a given output stream. We're going to use anonymous pipe, so here it creates the read and write end of a pipe. We are going to run a child process, so we use fork. And in the child process, we close the read end of the pipe because we only want to send output. We tie the write end or the output end of the pipe to the output of the child process. And then we execute the actual child process. Here we're running ls command with -l as the parameter. And here we're using the execlp system call to make it easier. Here it's easier to use execlp because we have a fixed number of command line arguments that we want to pass. In the parent process, we're going to close the right end of the pipe because we only want to read data from the child process. And then we wrap the pipe, which is basically an integer. Notice that pipe is defined as an integer. We wrap the integer, which is synonymous to a stream, into a buffer to make it easier to read the data, and wrap the buffer into an input stream object. This input stream object gives us the methods to use the stream extraction or stream insertion operators like greater than, less than, and get line to read data from that file buffer. And you can think of this as being synonymous to creating a scanner object to read data in Java. So you would use scanner and file input stream, etc. in Java. You're doing something similar here, creating a file buffer and wrapping it into input stream so that it's easier to read data. Then we'll print some kind of a fixed HTTP response header. This is the 200 OK header that we saw in the previous slides. And then we're going to read line by line. And again, same process, tag the new line that was not included and print the size of the line, the size of the chunk in hexadecimal, followed with the actual content. And then keep on running the loop, wait for the process to finish, and then finally send the end of response chunk. And this is how you can take data from a child process and send chunk by chunk to the server. Notice that here we do not know how much data the child process is going to generate, so we cannot know the content length ahead of time. So since we don't know the content length ahead of time, the chunked response is the best way to send. That means as you get data or output from the child process, you keep sending that to the web browser. Now let's say how to put it all together to build an actual web server here with this information. Typically, all of these web interactions will occur through what's known as a socket, which is a software handle created by the operating system for handling network interactions. We will typically use the socket with a with the TCP protocol using a IP address and a port number. Or instead of an IP address, you can also use a host name like www.google.com or os1.csi.miami.oh.edu, so on. Those are all host names. A socket handle is a file descriptor synonymous to a file, and socket handles tend to be lower operating system level primitives, which is similar to the pipe file descriptor that we saw in the previous slide. So for convenience, they're all wrapped into input-output streams. Here, typically in C++, we use what's known as the Boost library to ease creating and working with sockets. And we'll use the Boost library as an example here. So here, to use the Boost socket, we'll use the #include boost asynchronous IO header. Here we're going to assume that we have a method called serve client, which uses the logic from the send file and send command outputs that we saw earlier to process requests from a client and generate responses. So we're going to keep a simple main method, and here we're going to just process one request to keep things simple. Is a generic IO service object required for Boost. And then we create a endpoint here. Endpoint includes the IP address that we want to use. And here the port number, we can either specify a specific port number, or if I specify 0, the endpoint will automatically, it'll pick some port, and the port number will be assigned by the operating system based on which port is available at that given time. Then we create our server based on the endpoint. Here we are just printing that the server is listening on a port so that we know which port we got, because when we specify 0, the operating system can choose any randomly available port. So in order to know which port we are using, we need to print that. And then we wait for a client to connect. Notice that the client is just an input-output stream, except it's a TCP IO stream. So that means it's using the TCP protocol and it's going to do input-output to the client. And then once the client connects, we simply call the serve client method to read data from the client. So the serve client method will read the HTTP request, and then use the output stream to send a HTTP response back to the client. And this is how a web server is built. Typically, the process of accepting a connection and serving a client will be in a while loop, so the server will keep on looping. Here we don't have a while loop, just to keep things simple. Let's summarize what we have learned. So web servers are used to streamline operations. So given a web server, you have different clients that are interacting with it. Typically, a web server, when it gets a request, will take data from a file and send it. So we looked at how to take data from a file and send it as a chunked response. Then the other mode of operation is called common gateway interface, where the web server runs another program and gets its outputs and sends it back to the client. We also looked at the send command output method that uses this anonymous pipes to send the data. All of these interactions can be performed with chunked HTTP response, and we looked at details of the chunked HTTP response and how to generate chunked response from C++ programs. And then we looked at the idea of using boost sockets to tie all of this together to develop our complete web server that can send files or send outputs from a program to different clients on the internet.